In this video series, we are talking about mixed designs, and in the previous two videos, I reviewed the between subjects design and the within subjects design. That is because in a mixed design, we have both a between and a within subjects factor. The effects in a mixed design are estimated separately for the two types of factors. That is, we actually create two analysis of variance tables, one for between subjects and one for within subjects. An interaction of a between and within subject factor is a within subject interaction. So let's think about that a moment. What does it mean to be a between subjects factor? Well, it means that the individuals in each of the levels of the factor are uncorrelated or independent of the other levels of the factor. The levels of the factor are not correlated with each other. On the other hand, a within subjects factor is a factor in which the levels are correlated with each other because the same individuals are in each of the levels of the factor. So what would happen if you mix the two? What would happen if you take one factor that has levels correlated with each other and interacted that with a factor in which the levels are uncorrelated? If you think about it a moment, you should answer, well, you're going to have some correlation. That is, when you interact the correlated and on the uncorrelated factor, you don't get rid of the correlation of the correlated factor. You're going to have some correlation. It's almost as if you have a dominant factor, like I think about dominant genes and talking about the dominance of brown eyes over blue eyes in terms of hereditary. The hereditary conditions. It's the same sort of thing here. When you have a within and a between and you cross them, you end up with a within. So we have to treat the interaction of a between and within subjects factor as a within subject factor, which means we're going to have to consider the conditions for within subjects factor when we think of the interaction of a between and within subjects factor. In order to have the conditions for valid inference met, we have to have the between subjects factor meet between subject assumptions or conditions in order to be able to make a valid inference of the between subject factors. Similarly, if we're going to make a valid inference based on the within subject factors, we must meet the within subject assumptions. Now, when you cross these two factors and analyze the residuals after crossing the factors, you're actually providing a conservative check of the assumptions. That is, if I look at my QQ plot for the residual for the entire design and it shows me that it appears to be normal, then I can feel comfortable using the normality condition for valid inference on the between subject factor without checking it separately, and similarly for the within subject factor. So the analysis of residuals for the full design will provide a conservative check. If we don't have normality, we might want to look separately at what we would get for the residual for between subject factor and what we would get at the residual for within subject factors. Or we could simply state that we have not exactly met the conditions for valid inference, and therefore our probabilities are going to be rather rough probabilities, approximations. We've done that in the past when we haven't met the conditions for valid inference, and the same would be true here. Of course, when we're dealing with normality, we're mostly interested in the normality of the sampling distributions, so if we have a large enough sample size, then we may be okay anyway due to the central limit theorem. The example of the mixed design that we're going to look at in this video series is one between and one within subjects factor. So you can go beyond one between to more between subjects factors, and similarly you can go beyond one within subjects factor to more within subjects factors, but we're going to start with the simplest of mixed design, one of each, one between and one within subjects factor design. Now, in this design, the interaction is typically the only thing that is relevant, the only thing we're going to be interested in, and I'll show you that in the example that we're going to use. But before we do, I'll remind you that in the past, when we had interaction with between subjects factors, if we did not find interaction, we were interested in the main effects. That is typically not the case in the mixed design. The example that we're going to look at is using data from a study of alopecia in women, that is, hair loss. And in this particular study, there were some of the women put into a placebo condition, and some of the women were put into a treatment condition where they were provided minoxidil, and the brand name for that most of us are familiar with, or many of us may be familiar with, is Rogaine. Rogaine is a drug for hair loss, and so this is going to look at, or this study did look at, we're going to borrow the data from this study. This study did look at whether or not using Rogaine could prevent hair loss or perhaps even increase the amount of hair that one had. And this was done entirely with women. If one was interested in seeing whether the drug worked well with men, we would have to do a separate research study with men. But let's go ahead and use these research data for our example purposes. Now, as with the within subjects design, we're going to have two formats because remember, we're going to have a within subjects factor. We're going to have a between and a within. So we're going to have variables in the wide format and variables in the long format. Let's look at what these are going to be. We're going to have an ID for each participant, and that ID number is going to show up in both formats. Then we're going to have a treatment condition, and this will also show up in both formats. The treatment condition is placebo or treatment. Now, each woman is going to be assigned or was assigned to either the placebo condition or the treatment condition, not both. So what kind of factor is that? That's a between subjects factor. So given that the units in the treatment condition are independent of those in the placebo condition, the condition of the study, which is labeled here as treatment, that might be a little bit misleading because we have the treat is the variable, but the variable can be placebo or treatment, those two values. But each woman is in either the placebo or the treatment, not in both. So this is a between subjects factor. And that factor is going to be shown in both our long and our wide format. In the wide format now, we have week 0, 8, 16, 24, and 32, and we're going to treat those as levels of a factor rather than as quantities. And those levels of a factor are going to be, there's going to be 5 of them, 0, 8, 16, 24, and 32. Those levels of a factor represent a single within subjects factor because we're going to measure the amount of hair for each woman. Now, what was done here is they actually measured out a little area on the scalp, and they would take the hair and pull it up from that little area on the scalp and cut it close and weigh it. And they would do this at the 0, 8, 16, 24, and 32 week intervals, but then they also divide it by the number of days there were in an interval in order to get an average daily weight gain. So they're literally taking the same amount of surface area on each woman's head, cutting the hair on that surface area, and weighing that hair in hopes that in the treatment condition, if the drug is effective, they will find that they get better weight growth than they do in the placebo condition. So you can see the within subjects factor in that wide format. Those 5 quote unquote variables are actually the 5 levels of one variable, the weak variable. And every participant appears at every level. So that's a within subjects factor, whereas they only appear in one level of the treatment condition, they appear in every level of the weak condition. Then if we go to the long format, we'll actually create a time variable in which we indicate the week number in the study. That is 0, 8, 16, 24, 32, and then weight would be the daily average weight gain in milligrams per square centimeter. That weight is actually appearing in each of weeks 0, 8, 16, 24, and 32. So again, the same data, but in a different format. Let's go ahead and call up our R, and let's actually read in the data here. We're primarily going to be focusing on the long format, but there is one time in which we're going to need the wide format. So I'm going to go ahead and read it in both formats, and also that will give us a chance to look at both formats. Notice that in both formats, in addition to reading in the data, I'm going to indicate the factors. In the wide format, that's going to be the ID number and the treatment, the between subject factor. I don't have in the various weeks because they're already in my Excel spreadsheet in week format, so that will be brought in automatically. In the long format, however, time is going to be an additional factor in which I indicate the week number for that variable. Probably the best way to make sure we understand this is to actually load this in and look at these. So let's start with wide. So what we see here are ID numbers. That is going to be, of course, a factor. Treatment, which is also going to be a factor, and it's going to be a between subjects factor. Notice we have just 8 women in this study. 4 of them are in the treatment condition. 4 of them are in the control condition. Then it looks like what we have is 1, 2, 3, 4, 5 variables here. And if we were doing a multivariate analysis, which is not what we're going to be doing, but it is an option if you know multivariate analysis, we're going to be treating it as univariate analysis, meaning that we're looking at this as actually one variable with 5 different levels, but in the wide format, it appears as 5 different variables, but they're actually levels of or different conditions for week. And so everyone gets week 0, everyone gets week 8, 16, 24, and 32, which is why that's a within subject variable. So treatment, you're only in one level of treatment here, 4 women in one, 4 in the other, and they're independent of each other. That's a between subjects, but week is a within subjects factor because everyone is going to be measured every single week. Let's look at the wide format. In the long format rather. In the long format, we now have what appears to be, it looks like we went now from 8 units to 40 units, but the reason that went to 40 units is because if you think of it back here in the wide format again, we have 8 women measured 5 times. 8 times 5 is 40. So what we're doing now is we're actually adding in the week as a single variable. Here it is. I've listed it as I called it time. So we have time 0, time 8, time 16, time 24, time 32. And then here is the weight for each of those times. So time is not independent. That is, the times are not independent. Individuals are going to appear at every time, but treatment is independent. All right, so we really have one between subjects factor treatment, one within subjects factor time, and then our quantitative response measure, which is weight, and wide format and long format. All right, so with that as our preliminaries, let's go ahead and analyze these data and look at an example of analysis for a mixed factor design. We'll do that in the next video.